Question 8. This person works for an accounting firm. She receives an annual salary which is paid in equal instalments. She's calculated that so far this financial year she's been paid 0.416 recurring of her annual salary. Express 0.416 as a fraction of its lowest term. So 0.416 recurring it's just the dot above the 6, so it's just the 6 recurring. So if we say that's x, to turn it into a fraction, we want to keep timesing it by 10 in order for us to get anything after the decimals the same, and then we can subtract them and the decimals get eliminated. So if I go times it by 100, so I've got 41.66666, etc. Times it by another 10, so I get 416.6666. And you can see here that these have the exact same numbers after the decimal. So if I take them away, they get eliminated. So if I do this one, subtract this one. So if I do 1000x, take away 100x, the decimals get eliminated, so I just need to do 416, take away 41. So on this side I'm left with 900x, and that equals 375. So if I just wanted x again, I could just divide 375 by 900, and now all I need to do is simplify it. So off the top of my head, I would divide it by 5 to get 75 over 180. I could divide it by 5 again. 15 over 36, so divided by 5 again. So that's 5 over 12. Yeah. So we got 5 over 12 is our final. Divided by there. So next one, using your answer to part A, find the number of months that the pays that she's received. Well, if it's 5 out of 12 months, then that's 5 months. It was just the top number. Question 9. This person follows the information about the amount of fuel his car uses. So when he's 30 miles per hour, he's doing 54 miles per gallon. When it's 50, he's doing 60 miles per gallon. When he's 70 miles per hour, he's doing 50 miles per gallon. During one journey, he drove 50 miles per hour for part of the time and 70 miles per hour for the rest of the time. He drove for 3 hours at a speed of 50 miles per hour. For the whole journey, he uses 4.6 gallons of fuel. So for how long did he travel at 70 miles per hour? You must show all your workings. So when he is going 50 miles per hour and he's taking 3 hours to do that. So if he's going 50 miles in 1 hour, 3 hours is going to be doing 150 miles. So if it is 60, because he's doing 50, so I'm looking at this row, so 50 miles per hour is 60 miles per gallon. So if he's going 150 miles, we need to see how many 60s go into it. So I want to do 150 divided by 60, which is 2.5. So he's using 2.5 gallons. So in total, he used 4.6, but he's already used 2.5. So he's done 4.6, but he's used 2.5, so that leaves him with 2.1 left for the 70 miles per hour one. So if we were to work like we did for the first one, we would have 70 miles per hour times however many hours equals however many miles. However many miles times our, so it's 70, so it's 50 per divided, sorry. So when we split that into 50, we get 2.1. So if we were working backwards, something divided by 50 is 2.1. I just need to times 2.1 by 50, so it's 105 miles in total. And then how many, 70 times what is 105? So that's just going to be, divide those two to get 1.5, because you need 1.5 to get 70. So we had the 2.1, we times it by 50 to get 105 miles that he's taken. And if he's doing 70 miles per hour and he does 105 miles, just divide those two and you get 1 hour and a half. Question 10. Astronomers use astronomical units, so AU, to describe distances in our solar system. The distance between the Sun and the Earth is 1 AU. 1 AU is 1.496 times 10 to the power of 8 kilometers. Correct to the nearest 4 significant figures. The distance of Pluto from the Sun is 5.913 times 10 to the power of 9 kilometers. Correct to 4 significant figures. So we've got the distance from the Sun to Pluto. This person says that the distance from Pluto from the Sun is less than 50 AU. Use suitable approximations, estimate the distance of Pluto from the Sun in AU to show that Sian, or Siobhan, or however you say that, is correct. You must show all your workings. So if I was to do this without suitable approximations, I would, because I could do it on my calculator, but obviously I need to use approximations to not do it on my calculator. So if I was doing it on my calculator, I would do my distance, because it's going to take me that long for the Sun, and if 1 AU is 1.496 times 10 to the power of 8, I just want to divide those two. So I could do that on my calculator, but obviously this is a non-calculator paper. So I want to approximate this, so suitable, well, I would just turn that to 6 times 10 to the power of 9, so we just round it differently. I would change that to 1.5 times 10 to the power of 8. I could turn it to 1, but that's a bit too low because it's 0.49, that's very close. So now I would divide them, and when we're dividing in standard form, we just need to do 6 divided by 1.5, which is 4, and then 10 to the power of 9 divided by 10 to the power of 8, which is 10 to the power of 1. So we got 4 times 10 to the power of 1, which is just 4 times 10, which is 40. You can check that by just putting this in your calculator. A light year is the distance light travels in 1 year. 1 light year is approximately 63,000 AU. Estimate the length of a light year in kilometers. Give your answer in standard form. So if we know 1 AU is 1.496 times 10 to the power of 8, we want 63,000 AU. So if I just had a calculator, I could just times those two. However, I don't have a calculator, so again I'm going to approximate my 1.496 to 1.5 times 10 to the power of 8, and I'm going to change this into standard form so I can multiply them quite easily. So that I'm going to put 6.3 times 10 to the power of 1, 2, 3, 4, and I just need to multiply them. So I'm going to do 6.3 times 1.5. You need to take a bit of workings out to do that, but that is 9.45, and then 10 to the power of 4 times 10 to the power of 8. So like the first one we would subtract in, and this one we just add them, so 10 to the power of 12. So our answer is 9.45 times 10 to the power of 12. You'll probably get a similar answer if you just put these two in your calculators, just to check. Okay, question 11. During a chemistry experiment, it was found that a particle lost 3/4 of its mass every second. The initial mass of the particle was 160 milligrams. Calculate the mass of the particle after 4 seconds. Circle your answer. So it loses 3/4 each time. So it's left with 1/4. So you could do this a number of different ways. You could find 3/4 of 160, take it away, find 3/4 of that new number, take it away, find 3/4 of that new number and take it away. I'm just going to find 1/4. So if he loses 3/4, he's got 1/4 left of 160. So you just want 1/4 of 160, so divided by 4. So that gives me 40. Then I want 1/4 left of the 40. So divide 40 by 4, which is 10. Then I want 1/4 left of the 10, which is 2.5. Then I want 1/4 left of 2.5, so I want 1/4 of 1/4, which is 0.625. So that one, 0.625. Write down a formula for the mass m in milligrams for the particle length t. Well, because this is basically like if I want to do it compound interest, so I would say the mass, because that's what we're working out, is going to be, I started with 160, I want 1/4 of it each time, so 0.25 for the however many times I'm doing it t. So that's basically like compound interest, where we have our amount, we times it by our multiplier to the how many times we're doing it. Okay. Okay, this place is a company that makes vases, however you say it. They make one of their vases in 2 mathematically similar sizes. It covers the surface area of each vase. The surface area of the smaller one is 400 centimeters squared, and this one is 3600 centimeters squared. The height of the large vase is 48. Calculate the height of the smaller cage. So when we go in similar shapes, you want to go, what's my multiplier? So how do I go from this height to 48? Now the thing we're using in this is the surface areas. So how do I go from 3,600 centimeters squared to 400 centimeters squared? So you can see that it's by 9. So from 3,600 centimeters squared to 4,000 centimeters squared, I just need to divide those two, and I get 9 centimeters squared. So my multiplier for area is 9 centimeters squared. I want to do a length. That is not centimeters squared, that is just centimeters. So to find my multiplier for length, I need to change this from centimeters squared to centimeters by taking the square root. So the square root of 9 is 3. So I know the lengths are 3 times as big. So I just need to do 48 divided by 3, which is 16 centimeters. The heights of the Year 11 girls at a school were measured. Nia has started to draw a histogram of the results. There were 24 girls in Year 11 whose heights were in the group 155 to 160. Use the information to complete her histogram. So this basically means histograms. The first thing I would do before I even read it, which I should have done, was just to calculate the area of each of them, because your areas of these rectangles give you your frequency, because frequency density is plotted instead of frequency on your y-axis. This information here is saying that the area of this rectangle I'm going to draw here is 24, and it goes across 5, and we should know that area of rectangle is just length times width. So it goes across here 5, so 5 times what is 24. So you just have to divide those two, and you get 4.8. So 5 times 4.8 is 24, so you want to go up 4.8, and that is 5 there, so they're going up in 2, so 2, 4, 6, 8, so it's going across there and down. So that is 24, all of that is there. Now, before I go on to the next page, I'm just going to spend a minute calculating the areas. So I obviously know that's 24. This first one is going across 10, and it's going up 2, 4, 6, so that is 10 by 6, that is 60. No, it's not going up to 6, is it? It's going up 0.6, sorry, that's 0.6, which is just 6, not 60, my bad. This one is going across 10 and up 2, so that is 20. This one is going across 5 and up 6, so that one's 30. This one's going across 5 and up 8, so that is 40. We've done the 24. And this one is going across 10, 20 and up 1, so that is just 20. So now I've just done that just to save myself a little bit of time. Might not even save me in time, but just to save myself a little bit of time later on. Nia has started to do some data analysis on the heights of the Year 11 girls. She's estimated the median and the upper quartile as shown in the table below. Use the histogram to calculate an estimate for the lower quartile of the heights of the Year 11 girls. So you should know that your lower quartile is just a quarter of your total. And I don't know my total. What is my total? I can just add up all these numbers that I just calculated. So 6, add 20, add 30, add 40, add 24, add 20. And you should get 140. So a quarter of 140, just half it, 70, half it again, 35. So my lower quartile is the 35th person. So now I'm looking for the 35th person. Got 6, got 20. So it's going to be in this one here. So it's going to go in just about here. Because you want, I'll show you why now. Oops. You want 6, because you want an extra 9 people. We've got 6, we've got 20. We want an extra 9. We want this area to be 9. And 6 times what is 9, basically. Because we've already got 6, we've got 20. We need an extra 9 people. So the area of this bit has got to be 9. And because it goes up 6, we want to know how many it goes across to make the area 9. So 6 times what is 9 is 1.5. So actually it was a bit over than what I said. I'm just going to get rid of what I just drew. So it's actually 1.5. So it's just going straight through the middle of that line. So if I read across, that's going to be 146.5. So our lower quartile is 146.5. So they needed an extra 9 people because you already got 6, already got 20. The area of this extra bit had to be 9. So 6 going up times what across is 9 is 1.5. Okay, question 14. The diagram shows a simplified model of part of an engine. It shows a belt which runs around 3 circular cogs. The engine rotates cog 1. Cog 1 rotates the belt, which makes cog 2 and 3 rotate. Lovely. A, B, C, D, E, F. Straight sections of the belt. AB is 12. They wrote that there. Yep. CD is 34. Yep. And EF is 29. Blah, blah, blah. Radius of cog 1 is 6. I'm just going to drop that on there. Radius of cog 2 is 4.5. Again, write that on there. Radius of cog 3 is 3. What is the length of the arc AF? So an arc is a curve, so they want that length there. So from A to F. It's in terms of pi as well, so you don't need to use your calculator. Obviously, it's a non-calculator paper. So that is part of the circumference of a circle. You should know that the circumference is pi times your diameter. And then I've got a quarter of my circle, so I want to times that by quarter. So I would do pi times my diameter. If the radius is 6 and the diameter is 12, times a quarter. So pi times 12 is just 12 pi. If I want a quarter of that, I just divide that by 4, which is 3 lots of pi. So our answer is 3 pi. So that length there is 3 pi. Calculate the total length of the belt. I'm just going to do it on this shape just so you can see what I'm doing. So we've already got, if we highlight what we already have, we've got 3 pi, we've got 29, we've got 34, and we have 12. So in order to do this one, we're going to do exactly the same as what we just did earlier. We're going to do that the circumference is pi times our diameter, which in this case is 9, and times, this time we've got 120 degrees out of 360. So 120 out of 360, which is the same as a third. So we want a third of 9, which is 3, so that length there is 3 pi, as well as the last one. This next one down here, so we've got the circumference is going to be pi times our diameter, which in this one is 6, times 150 out of 360, which is the same as 5/12. So we want 6 pi times 5/12, which is the same as 6 divided by 12, which is a half. Half times 5, which is 2.5 pi. So now we have our extra 2 lengths. We can just add them all up. So I'm going to go on the next page now. So we've got all the pi's first. We've got 3 pi plus 3 pi plus 2.5 pi. Those are all the curved bits. Then we want to add all the lengths, so 12 and 29 and 34. So that should give you 75 plus 8.5 pi. You can't combine those because one has